This is the first mini lecture for section 6.1 of the textbook. In this section we're going to begin to talk about fractions and rational numbers, something that still gives even a lot of college students, math majors, even graduate students, a lot of trouble. So we're going to begin with the basic concepts. Let's think about the fraction 2/3, for instance. We can think of the fraction 2/3 as a set of instructions. So you start with the unit, which could be a shape, or a pie, or a line segment, a group of objects, a bunch of students, a loaf of bread, a pizza, whatever. It's just something. Okay, and that object you're starting with is called the unit. Whatever that unit is, you're going to imagine dividing it into 3 equal parts, or perhaps you literally do that. You cut it up into 3 equal parts, or divide it out. And then you take 2 of those parts. So you can think of the 2/3 as the amount that results, but you can also think of 2/3 as the action itself. So 2/3 could be that piece of the loaf of bread that you end up with, or it could be the action that results in that piece, the process. So one thing I often like to say, because it rhymes, and it's true, is that a fraction is an action. So that's the idea you should have in mind. We'll talk about the definition here, but the definition doesn't really tell you much about how we're going to use these things. So the definition says that a fraction is an ordered pair of integers a and b, where b is non-zero. You write it a over b. The integer a is called the numerator, and the integer b is called the denominator. So the definition doesn't really say how we're going to use a fraction. It just says it's a pair of numbers, basically, where the second number can't be 0. Okay. Now we have these long words that we use to refer to the parts, the numerator and the denominator. And they play different roles, and I think it helps to understand that if you understand where the words come from. The denominator tells you something about how much each part is worth. The numerator tells you how many. So we have numerator over denominator. The root of the word numerator is this num, which is also the root of the word numero in Spanish. Right? It means number. In denominator, the root is that word nom, which gives rise to the word nombre. In English, there's various words that come from that. The word name doesn't directly, but there's other words in English that do come from that nom root, and they all refer to names. So the thing on the bottom, you could think of it as the namer, the namer. So it's like number over namer. The thing on the top is an amount. The thing on the bottom is it's more like a name. It's more like a label. Okay, it tells you how much each part is worth. This word denominator, it's related to the word denomination, which you hear when you're talking about money, right? If you have dollar bills, $5 bills, $10 bills, $20 bills, those are all called different denominations of money. So let's talk about a number of different ways to illustrate fractions. The first is colored regions. With colored regions, the unit is a shape that is divided into regions of equal area. So, you could have, let's say the fraction 4/6, 4 over 6. And you just pick a shape. I'm going to pick a hexagon, because it's over 6, but it doesn't really have to be that necessarily. Just pick a shape that you can easily divide into 3 equal parts. Sorry, into 6 equal parts. Okay, so we've got our hexagon, and then we divide it into 6 slices. And it's 4 over 6, so I'm going to shade in 4 of those. Or let's try, let's say 5/8. And again, I can really use any shape that is easy to divide into 8 equal parts. We could draw an octagon, but that's kind of a pain, so let's just do a rectangle. And there's lots of ways I could divide it up into 8 equal parts. Let's just do it like this. So I'm going to kind of divide it into quarters and then divide each of the quarters in half. And that gets us 8 equal parts. And we know we need that because the denominator is 8. And then the numerator 5 tells us we want 5 of those parts. So just shade in any 5. It doesn't really matter which. Okay, so yeah, that's how colored regions work. It's important when you do these on paper that you at least attempt to make the parts equal size. When you teach, you'll definitely be drawing these on the board, stuff like that. It's important that you try to do it carefully. Okay, so next we have fraction strips. Fraction strips it's kind of an extension of colored regions, but we use them a little bit differently. We can use fraction strips to illustrate higher level concepts, like comparison of fractions, deciding which fraction is larger than which. We can use them to identify equivalent fractions, which we'll talk about in one of our mini lectures in this section. So for example, let's illustrate, let's say 2/3 and 3/4. Okay, so you begin with a long skinny rectangle. And this is our 2/3 rectangle. And just to emphasize how this works, I'm going to go ahead and draw the other rectangle first. This will be 3/4. The idea when you use fraction strips is to use the same strip for all the different fractions. That way it's easy to line them up and compare the fractions side by side. Okay, so 2/3. I want to try to divide this into 3 equal parts. I'll do that as carefully as I can. Okay, so there's our 2/3. Now let's do 3/4. So divide it. Yeah, I divided it into half and then into half again. So that makes it pretty even. And then I shade in 3 of these. And then when I'm done with this, you can compare them side by side now and see which one is larger than which. How do they compare? And we see that 3/4 is a little bit larger than 2/3. And if you do this pretty carefully, that should show up on your own picture.